तो यूट्यूब वीडियो କାନରେ ଟିକେ ଠିକରେ ଲଗେଇଦିଅ। Okay, I hope I am audible. So what we'll do is we'll have a short discussion on MATLAB for about 2 classes, 2 to 3 classes, in which I will summarize what is available in MATLAB and how you approach it. So that will be a supplement to your MATLAB course or lab that you have done. After that, once that is over, so maybe today and the next class, after that is over, then we'll go to a detailed study of MATLAB. So this will give you a stepping stone sort of thing. So you are acquainted with the terminologies that we are going to use in MATLAB. So that we'll do first. Once that is over, then we'll go to the same thing, but in detail. So examples we'll see, um, example of programs we'll see, those things we'll see later. But how to write a program, what are the components that are necessary for writing a program in MATLAB, that part let us first discuss. So this is today we will have 2 lectures. Uh, so then I will have over 2 more lectures. Maybe tomorrow or day after tomorrow we'll have 2 more lectures. So that will complete this basic on the foundation or the stepping stone. So to start with, let me tell you where you can refer, what you can refer. One is a book, Getting Started with MATLAB. For every version, this person has written a book, Rudra Pratap. So you get any one of his book. It's a small book, not very thick. It's a very thin book, about 100 pages and 100 to 150 pages. So read that book. Um, that book is a very good for starting MATLAB. I actually learned MATLAB from this Rudra Pratap MATLAB. I learned from that. What I did is I read that book chapter wise, each chapter, and each example in the chapter I executed on the computer. Then all programs given in the chapter, that also I tried to solve on the computer. So that is how I learned MATLAB. Now, if you want any in-depth knowledge on MATLAB, then you can go to directly the MATLAB site. In the MathWorks site, there is a MATLAB manual by MathWorks. There are many, actually many manuals you will find. So depending on our requirement, we can refer to one of those manuals to learn about MATLAB, how to program, etc. Now, on the one of the very attracting feature of MATLAB is once you open the MATLAB program, on the command window you can write help, then it will give you a list of commands on which you need help. So go to those commands, it gives you detailed of how to use those commands that you are using in MATLAB. Everything is available. If you know the commands, straight write help, then the name of the command, or help name of the function. If you want, you are using a function like sine function, help sine, then it will write how to use sine function. So everything will be there on the screen. You can follow that. So this is about self learning of MATLAB. You can always self learn MATLAB easily. Now let me tell you what is MATLAB, what is meant by MATLAB. MATLAB stands for Matrix Laboratory. Mat is for matrix, lab is for laboratory. As you know, most of the problems that we do in science and technology and engineering, all these problems ultimately boil down to one equation. Most of them. That equation is Ax is equal to B. Capital A, small x is equal to small b. All these A, X and B are matrices. Ultimately, all equations we can write in this form. And this equation is to be solved to solve any problem. Therefore, we always deal with matrices. So, people have designed this MATLAB, which has its counterparts also. Scilab is free, MATLAB is very costly, but Scilab is free that you can use. MATLAB in mobile phone, I think I had given the link. That link you can use, that is free. Uh, so these things are free, and MATLAB is matrix laboratory. It is a laboratory, a numerical laboratory sort of thing, which you can use using your computer. So if you have installed MATLAB on your computer, you can go into that lab and do experiments on different topics related to mathematics. It usually does, as I told you, it is usually involves matrix computation. So by the time we complete this series, you will get some knowledge on matrix computation also. Then you will also know the graphics, how to draw or plot graphs using a program. Using these MATLAB programs, you can be able to draw graphs, etc. So that is another point that you will be knowing. Then you will also know how to write a program. So programming also you will know. These programs, like in C, you write the programs and store that program in a file which has a C extension. Suppose your program is program 1. So you write program 1 dot C, that is for C program. So within that file, you write your program, then save it, then you run the program.c file, execute the program.c file. Similarly, in MATLAB, these files are called M files. So you write a program, say called program 1. So program 1 dot M is your program file. There are two ways. One is if you want to store it permanently, you write a file, write your program into a file. But if you want to see it temporary, then you need not write the program into a file. Straight away on the command window, you can give the command like I'll define a is equal to 5. Write in the command window, write a is equal to 5. Then write b is equal to 10. Then write c is equal to a plus b. So that will give you c is equal to 15 on the command window. The same thing you can write in the program file. Let us write, use a program file add. So add.m is your program file, mat file or m file, add.m. So add.m you create. There you write a is equal to 5, semicolon, give a semicolon, a is equal to 5, then you can give a semicolon. Even if you don't give a semicolon, there is no problem. But the only thing is, if you don't give a semicolon, when this file is executed, whatever is written, whatever is given in the command or assigned, everything will be displayed on your screen. So to suppress the display on the screen, we put a semicolon at the end of a line when we are writing a program. So write a is equal to 5, then next line write b is equal to 10 and semicolon, then write c is equal to a plus b semicolon. Then execute it or run it in your MATLAB. After that, on the command window, write c. So that will give C is equal to 15. So that is how you run the program and how you write the programming. It's a very simple example. And then there are certain other things, advantages of MATLAB is toolboxes. Since we use MATLAB in different areas like signal processing, people in statistics they use it for statistics and probability. Optimization like neural network optimization, razor search optimization. There are different types of optimization. People use optimization, and then people use symbolic math also. So all those things are available as toolboxes. For antenna, we have a toolbox, antenna toolbox. For microwave, we have a RF toolbox. So these are available in MATLAB toolboxes. But this is toolbox is add-ons. So you keep on adding. Basic structure is one, which is MATLAB. It does not include any toolbox. You can develop your own toolbox by writing programs, or you can use the toolboxes of MATLAB which are available. But like you have to purchase MATLAB, you have to purchase also the toolboxes. The toolbox that you need, you can purchase that. If you do not purchase that, you write a program for your requirement. Toolboxes save your effort, but they are not essential. MATLAB is essential, toolboxes are not essential. So basically about MATLAB, this is what is available in MATLAB. Uh, you have, it is a interactive numerical computing environment. So it interacts with you, with the person who is writing the program. It uses or computes matrix, and then you can plot uh, different types of plots, 2D plots, 3D plots. All those plots can be done. Movies you can make using plots. You can write programs using M files. There are other formats of programming files that we'll discuss later. Then you can use toolboxes. And this is what is MATLAB. Then let us see what are the advantages. Why we use MATLAB? What are the advantages? The first advantage is it is easy to use. It is not very difficult like Fortran or C. You are not required to write 10 15 lines of code for a simple thing like summation. If you want to sum, you just write sum 1 plus 2 plus 3 4 plus 4. You want to do that sum, so write the series and write the sum. Otherwise, in the program, if you are using C or Fortran etc., then you have to use a loop. Here, without using the loop, you can write a sum, and so that is how it is easy. Interactive environment, you continuously interact. Whatever you want, you tell the computer tells you, reacts back. So that way you, every step you can refine your programming. If you are making any mistake, those mistakes can be refined, corrected. So those things can be done. So that is a major advantage which is not possible with other uh, uh, high level languages or mid-level languages like C. You have to write the complete program, then you have to run the complete program there, then there will be errors. You will go to the errors and rectify errors, come back again, run that. So that takes a iterative process, a repetition of the process. By the time you are fine or your program is ready, it takes a long time. But if you have interactive environment, that takes a short time because immediately you find out there is an error in the program. And so that part you can easily do. This error means spelling mistakes type of thing, not the logical error. Logical error you cannot find in MATLAB, neither in C, high level, low level, or MATLAB. Nowhere you will find out where you have the logical error. Only when you look at the answer, you are not getting the proper answer or proper result. There you know that there is a logical error somewhere. but spelling mistakes, etc., you can easily find out using this. So it is easy and interactive environment. Then its algorithms for numerical techniques that you use are very fast. Uh, you can most of the time when you start writing a program in other languages, because you are not acquainted with writing the program or thinking in proper way, proper sequence to write a program, unless you have experience, we make mistake, or we may write long programs which take long time, large time for execution. But these algorithms, numerical algorithms that are used in MATLAB, they are optimized. So you need not write a long program, you will write a short program and it is optimized, it will be very fast. So computation is fast, less computation load is required. Then this software is not very expensive compared to the value that you get. It is, you can say, it is value for money. The amount we spend on this software is returned back to us, because it is not very expensive for the job that we require it. Then when you do it, when you use it, you will enjoy it, because everything that you are writing in the form of a program, you are seeing the result. So it is like a fun. Uh, it is fun. Environment is easy, and you can learn linear algebra. You know what is matrix? Matrix is a part of linear algebra. In mathematics, there is a branch called linear algebra. In the linear algebra, you have matrix. In matrix, you have to learn many things like what is rank of the matrix, what is size of the matrix, what is eigenvalue of the matrix. From the matrix, you can find eigenfunctions, eigenvectors. Everything comes under linear algebra. So you will be acquainted, or you can learn easily linear algebra once you deal with this MATLAB. And therefore, ultimately what you have to do is you have to think in terms of linear algebra when you are writing a program in MATLAB, or when you are writing a program for a particular problem. Think that problem, or put that problem in the form of linear algebra. Once the problem that you are attempting is brought into the form of linear algebra, then you can easily write the programs. So that is more important. Similarly, you have to use calculus in the form of linear algebra. That is also important, and calculus can be done using on this MATLAB. Why it is in calculus? What you do? Basically, we use two things: derivative and integration. Integration is nothing but successive summation. Derivative is nothing but successive differentiations, or differentiation is successive subtractions in a proper manner, in an algorithmic way. So summation and subtractions are same thing. Basically, sum and addition and subtraction both are same thing. You know, one is plus, one is minus. Otherwise, you are adding. But particularly, you are adding in a positive way or in a negative way. They are same thing. So they form a group in terms of linear algebra. They form a group, closed group. Ah. So calculus is nothing but linear algebra also. So you will be thinking in terms of linear algebra. Then you should have some background knowledge. For example, uh, we are given two matrices, A and B. Then if you are acquainted with matrices, you know that AB is not equal to BA. A into B is not equal to B into A. Those background knowledge you should have. Like if it is this A is equal to B will be equal to B is equal to A under certain conditions. There are certain conditions under which this is satisfied. For example, suppose A is a 1 cross 1 matrix and B is also a 1 cross 1 matrix. In that case, A into B will be B into A. Example of a 1 cross 1 matrix is A is equal to 2. 2 is a 1 cross 1 matrix. its number of rows is 1, number of column is 1. So it is a 1 cross 1 matrix. B is equal to 3. It is a 1 cross 1 matrix. Row number of rows is 1, number of columns is 1. So AB is equal to BA. In both cases, you will get 6. That is simple numeric multiplication of 2 into 3. So where that is possible, only in that condition, AB is equal to BA. Otherwise, it is not possible. AB is not equal to BA. Always AB may not be equal to BA if we are given two matrices. So this background knowledge is necessary. Now and then you should know whether if A and B both are symmetric matrices, is AB a symmetric matrix? So if you multiply them, whether you are going to get a symmetric matrix or you are not going to get a symmetric matrix, that you have to know. So similar things you have to know. What is a positive definite matrix? And these background knowledges are required. Similarly, what is eigenvalue decomposition of a matrix? So these are something. These are some background knowledge that you should have not only for MATLAB, for whenever you are writing a program uh, in the field of engineering, technology, or science, you require this knowledge, particularly linear algebra. We use mostly linear algebra throughout your course. Without knowing that you are using linear algebra, you use linear algebra, therefore it is a necessity always. Now, what are the components? So when you write a program, there are only two components. One is input, one is output. In the program, you expect that I will give some input. Program works like a black box. So that input goes into the program and it gives you a output. So there will be input and there will be output. What are the types of inputs and outputs that you can use if you are writing a MATLAB program? The inputs and outputs that you are using can be integers, can be real numbers. In the real number, they can be either single precision real number or double precision real number. Now, this is numerical. If it is not numerical, then it can be characters, it can be strings. Now, let me give you examples of this. Integers are 1, 2, 3, 4, etc. are all integers. Real numbers are 1 is a real number, but that you consider as 1.0. So there is a decimal extension. So those are real numbers. Now decimal extension can be up to 8 digits, 8 decimal points. So 1.1 you can write as 1, you can write it as 11 into e to the power minus 1. E to the power minus 1 is 11 by 10. Right. Similarly, usually single precision numbers are e to the power minus 8 or e to the power plus 8. That up to that precision is after decimal point how many numbers. Similarly, double precision numbers will be up to e to the power minus 16 or 16. So as uh, computer configurations increase, hardware configuration increase, this keeps on increasing. Now I think it is 16, no, so 32 and 64. E to the power minus 32 and e to the power minus 64. Up to that many digit you can handle it. So double means it is double precision. Whatever is after decimal, that has been doubled. Up to, suppose we say that 3 by 1 by 3. 1 by 3 with single precision you can write 0.3333 up to 32 number of 3's. But with double precision you can write that as 0.3333 up to 64 number of 3's. So that is what is double precision. MATLAB handles double precision. Integer definitely it handles. Real definitely it handles. Then it handles characters. Characters are A, B, C, D, etc. Similarly, 1, 2, 3, 4 numeric 1, 2, 3, 4 are also can be treated as character. They can be are treated as numerical value or character. Will see how to use them as character. For example, as I told you, program 1. In this program 1, program all characters you are using from A to Z, then 1 is also used as a character in that. Program 1.m, that 1 is also a character. For computer, it is a character. For you, it is numerical number. For computer, it is a character. So that is how you can use character. You can add characters, subtract characters. Everything can be done. Then there can be logical data types. Logical data types, A and B. If A is true and B is true, two conditions are there. A is true and B is true, then C is true. If A is true or B is true, these two conditions are true, then C is true. Which means you can say that suppose A is equal to 5. If A is equal to 5, that is true, and B is equal to 6, that is true, then C is equal to 10. And that you can say that. So those type of logical data types that we can use. And, or, nor, and all those things you can use using MATLAB. XOR, everything, not those things you can use. Then if you are using C or Fortran, there sometimes you require an array. Many times we require an array. And if you require an array, array can be one dimensional, array can be two dimensional, array can be n dimensional. Here you can, and there you have to define what is the dimension of the array. In MATLAB, you did not define the dimension of the array. That is the beauty of MATLAB. Without defining the dimension of the array, you can use array, because matrix itself is an array, m cross m or m cross n matrix. All matrices are m cross n. M was n1 is a 1 cross 1 matrix, which is 1, 2, 3, 4, etc. But all matrices are m cross n. So there are different arrays, right? Arrays of rows, arrays of columns. These are available in matrices. Therefore, by default, MATLAB takes all its variables as arrays. You need not define the dimension of the array. Whatever is the dimension, it will automatically take. You can define, if you want, you can define the dimension, but you need not define. It is not necessary. So if you are not comfortable, you do not know what is the dimension of the array, don't define it. Simply use the array. Another advantage is the variables are case sensitive. For example, if I write department, so with first letter as capital D, so that I can write department with first letter as capital D is equal to 5. And I can write department with first letter as small d is equal to 10. These two are not same. MATLAB will consider them as two different variables. Whereas if you write the same thing in Fortran or in C, there will be a conflict. For C and Fortran, department is always one variable, whether it is capital D or capital small d, little d. Irrespective of the type or irrespective of the case, and the C and Fortran, etc., they take it to be different variables. They take it to be same variable, but here if the case changes, it will be same variable. So you can have different variables with the same name. Advantage is you can write, suppose you write small a to define one variable. Capital A, you can define another variable. Small a, capital A, another variable. Capital A, small a, another variable. So using two letters, you have four variables now. Whereas using same two letters, either in C or in Fortran, you have only one variable. So it multiplies 2 to the power or number of letters, that to the power the number of letters that you are using. So that many variables So you need not think of new variables always.
Yeah.
Okay. And then you can always control the output format. How the what will be the output? Output will be in the integer form, decimal form. If it is in decimal form, how many points after the decimal point? How many numbers after the decimal point? Those things can be easily controlled here. And of course, that is also possible in Photon and C, but that feature is also available here. Then it remembers the command history. That is a major advantage. So if you give a command, it remembers the command history till you close it. MATLAB is closed till then it remembers the command, whatever command was given. So you can go back to whatever command you have written. So you need not repeat it. You need not repeatedly write the command. Write once since it remembers it. So search it there and come back to that. That command can be repeated. So this is a short about input and outputs, how to handle, what are the possibilities of using input and output, and what are the advantages or disadvantages of input and output in MATLAB. Then let us see how to define or how to handle files in MATLAB. There are different types of file. The most common file that you will use is the M file or .m file. Star, you can see here the star.m. Star is the name that you will give. Star stands for anything. So you can give any name, file 1, file 2, file 3, program 1, program 2, or your name, or you are doing an addition, so you write add, anything you can write. So that .m. So these are called script files and function files. Either it will be a scripting or it will be a function file. These are two different things. Script files can call functions files into them. So within the script file, you can write the name of the function file. When you will go to the function file, you will see that. So within the script file, you can write the name of the function file. For example, a is equal to sine theta or a is equal to sine 20. Now sine is a function, so you are using sine within the script file. In the script file, you are writing a is equal to sine 20. So 20 sine is a function for which you are giving the variable 20, or this each function has a variable. It can be of no variable also, but each function usually has a variable. A is equal to sine 20, or a is equal to say f20. F is a function, or a is equal to fun 20. Fun is a function that you have defined separately. So for fun, you will write a program, store that program as fun.m. Alright, so within the fun.m file, you will write the script for the fun function. How to write the script function, that we will discuss later. Now you write another program, program 1 or file 1, whatever you want. In that program, in the script, you write a is equal to fun20 or fun x. You have defined x earlier. Write x is equal to this much, then fun x. So that is a script file. This file is a script file. Which file? This program 1 is a script file, or file 1 is a script file which is calling the fun function. So both of them have extension .m, and this can be modified by you only who has created it. Then there are mat files. These are system files or files created by MATLAB. These files can be saved. These files can be read in your program with a load. With load means load is a command. So within the script file, you can write load, then give the name of the file. It will automatically read that file. Load star.mat star instead of star, whatever is available, that file name you will give .mat. It is the file which is created by MATLAB. You need not worry about what is it. We'll see or use some mat files later. For the time being, remember that .mat files are created by MATLAB itself. So they have created already when they have developed this platform, MATLAB platform, these files were developed. And as per your requirement, you can use them. But to use any file, you have to write the command load. So in the script file, you will write load, then file name, automatically that file will be loaded. Then there are mex files. Extension is .mex, mex files. These are MATLAB callable codes compiled from other language. For example, you are writing a code in C and C has been compiled. You have compiled that code that you can uh, import into MATLAB file using this start.mex file, or put that file as .mex file, save that file as .mex file. That can be file1.mex. Then here you can call them within the MATLAB. You can call them. So if you have written in other programs some files, you can call them into the MATLAB. So these are the three types of files that MATLAB can handle. There is another type new, it has come, star.p. This .p is a replacement for m. So if you do that .p, then nobody else can see your file. What is written within the file, that is not going to open. It is automatically locked. Nobody else can see, only you can see. Only the creator can see that file. Others cannot see that file. So that is for security, but you are not required to use that file. Those type of files. And then there are certain general commands that we are going to use in MATLAB. One is the online help. So that you can write as help is one command. Help win is another command, which is for the window version of MATLAB. Help desk is another for a format which you can use. Look for is another command, and demo is another command. All these commands are online help commands, which means if you are connected to internet, or if you are not connected to internet, if you are connected to internet, all these will work. Even if you are not connected to internet, help will definitely work. And if it is that, now suppose you want to know what is help, how help is working, you can write in the command window, just write help space help or demo space help. In this, what you are doing is fast help is saying that I need help. So that is the command. Help is the command. And on what you need help? On help I need help. Using help command, what I can do, that I want to know. So help space help. That gives you a detailed description of help. Instead of that, if you give demo, that means you are saying that the command is demo first. First word is demo. That is a command. So if you give demo, then demo is give a demonstration of the command that I am writing or the function that I am writing after this. So demo space help. It will give you a demonstration of how to use help. It will give you an example of how to use help. Demo space sign. It will give you an example of using sign. Right. So this is how you can get help. This is the most common one, common command for people those who are new to MATLAB. So in almost every 3-4 steps you require these commands. So at least remember help and demo. These you can always use. Then another is workspace, where you are working. WHO is who is working. Whose is which are the people they are working. Then what is what you are working with, whether you are working with a script file or other file that. Then clear is whatever is there in the memory, that is clear. Clear all is clear everything, or clear means whatever is there now in that program that has been clear. Clear all means everything from the memory will be erased. For the MATLAB, then you can start refresh. CLC is clearing the screen, clearing the command window, clearing the screen is CLC. Similarly, clear files, CLF. So these are some commands that you can use. If you do not know what to do with these commands, just write demo who or demo whose, demo what, demo clear, demo CLC, demo CLF on the MATLAB command window. That will give you a demonstration of what is being done. Or instead of demo, you can write also help. So that is one. Then what are the directory, in which directory you are working? So the directories can be present working directory. PWD is for present working directory. CD is you want to change the directory. So change directory is CD. dir is directory. What are the directories that are available within the directory? What are the files in the present working directory? Whatever directory you are within that, what are the files available? The a list of the files by dir. ls path to your directory. So everything can come from these commands. If you don't know, use help. And then there are certain general commands, which is computer. It will give the configuration of your computer. Clock, what is the clock speed that you are using? Or it will give you the timing. Date, more, version of the MATLAB. So all those things will come. Then termination. If you are writing a program, you are make some mistake. There is an infinity loop. Suppose you say within a for loop you are saying for no, 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 for you are using a if loop. If a is equal to 1, then you write something, some programs, some lines, or if a is equal to 1, write that. Then write something. After that you write a is equal to 5. Then uh, write end if. So once you within the if loop, everything is covered. When it comes to the last line, it says a is equal to 5. So if loop will not end because a becomes 5. If a is equal to 1, then only it will end. Otherwise, it will continue. So that will keep on continuing. Infinite loop. That is what is an infinite loop. So you want to stop your program in that condition. So you have to terminate that. Similar things you have to do. So in the command window, you write Control C. This great sign or hat sign before the C is representing control. So Control and C simultaneously press both these buttons, Control button and C button, and that gives you that terminates. That is one way. Otherwise, you can write quit or you can write exit. These things are to be written within the quit and exit are to be written within the program for termination, and Control C is in the command window that will terminate. So these are some of the general commands that we are going to use. Uh, if you have written programs, you might have used these commands. Then, what are the operations that you can do using MATLAB? One is the simplest operation or the most common operation that is required is assigning a value to a variable. Suppose a variable is equal to is a, so you write a is equal to 5. So the variable a is assigned a value 5 or value 5 is assigned to variable a. So assigning values to variable. Then you have to do a basic arithmetic. Arithmetic is plus, addition, subtraction, multiplication is star, division is slash, to the power is correct, or this I hat sign or great sign that gives to the power. So suppose x to the power n, so x great n means x to the power n. X slash 5 means x divided by 5. X star 5 means x multiplied by 5. So these are the basic 5 arithmetic operations that you will be using in MATLAB. Then another operation is semicolon. The screen output is to be suppressed. You do not want to see whatever is coming as the output of a line. When you are writing a program, you will be writing line by line. Each line, suppose a is equal to 5. Since you have assigned 5 to a, you do not want to see what is a in the screen, on the command window. So a is equal to 5. After that, put a semicolon. In that case, it will not show you a is equal to 5. But if semicolon is absent on the command window, the moment you run it, it will show a is equal to 5. So depending on whether you want to see the value of a or you don't want to see the value of a, you will either not use semicolon or use semicolon. Then there are operations for floating point number appearances, how the floating point number will appear. Like floating point means real number. 3.38, it can appear as 3.38, or it can appear as 338 e to the power minus 2, or it can appear as 38.3 e to the power minus 1, or it can appear as 300. No, so these are the things that in the way in which floating point number can appear. Any number you can take these numbers. And then functions like sine, cosine, logarithmic, etc. These are common operations. In common operations, you are going to use some simple functions. We'll discuss some simple functions later. Then quit. Quit is an operation in which you are going to leave the program. So the computer will leave or come out of your program. Leave the execution. It will not continue with the execution of the program. So once you know what are the operations up to this, then we should know on vectors, because we are mostly related with electromagnetics, or even you are not in electronics, even signal processing. Everywhere we have a variable which is called a vector, right? Which is that a matrix is form of a vector. So on vectors, you can create row and column vectors. Row vector means it is a matrix of rows, one row only. Column vector means it is a matrix of one column only. So it will be one row vector means it will be a row with different elements. For example, A is equal to 1, 5, 8, 10. So there are 4 elements. They form a vector A. Right? Similarly, they are in a row, or 1 below that, 5 below that, 8 below that, 10. That is a column vector for A. So you can create row vectors and column vectors using this. We'll see how they are done. Then linearly spaced vectors, that we'll see example. Don't worry about that right now. But if the vectors are linearly spaced, means the separation between vector is constant, or separation between different vectors, that separation can form a straight line. So linearity means it comes from a straight line. It is mostly related to linear algebra. So forget about that for the time being. Arithmetic on vectors, adding two vectors, subtracting two vectors. So those are the two arithmetics that you can do. Multiplying two vectors, dot product, not the cross product. For cross product, there is no arithmetic. So you have to write a program for cross product. But addition, subtraction, multiplication, those things you can always do. Then array operations. You have two arrays. Multiply those two arrays. So divide one array by another array. Take the power of one array. This dot is, you can see dot star means element by element operation. For example, suppose A is equal to 2, 3, and B is equal to 4, 5. Then you can multiply A and B as A dot star B, then 2 will be multiplied by 4, 3 will be multiplied by 5. This is called element by element operation, which means first element will be multiplied by first element, second element will be multiplied by second element, third element. So mth element will be always multiplied by mth element of the other matrix. Right? That is what is element by element operation. For that you have to use a dot. So array operations sometimes require element by element operations. It is not always a proper matrix operation. For example, A is equal to m cross n matrix. A is m cross n matrix. B is a n cross p matrix, then AB is m cross p matrix because m cross n and that is n cross p. So that will give you m cross p. That is a normal dot. A dot B will give you m cross p matrix. But element by element operation will not do that. So you have to have m cross n matrix. B will also has to be m cross n matrix. Then each element can be multiplied with the element of the other. Huh. Similarly, you can have math functions like sine, cosine, etc. operating on the vectors. So this is about vectors and how to handle vectors. Then let us see what more we can do. We can create a plot. We can print or take a printout of that plot or do a plotting of that. So those are two things that we can do for plotting, creating and plotting. So we can create points. We'll plot. You know what is a plot? Plot is basically combination of point, addition of different points. You take different points. If the point is present, you have a black point. If you don't have a point, it is white. So black and white. So each curve, each plot is a combination of dots, black dots and white dots. If they are very fine, then you don't see them. But if you expand the photo, take a photo or take a graph, expand it, keep on expanding it, zooming it. You keep on zooming it, you will see after some time that is breaking into points. But basically, that is combination of those points. We can do two-dimensional plots. You can do three-dimensional plots, animations of 2D, 3D, and of the plots we can do a printing. You can take out a print, connect it to a printer, and you can do a printing of those plots. Then I have already discussed about script files. Script files are program files that you will require. So you can create, write, and save a script file. We'll learn how to execute the script file, what are the path, in which path, where it will be stored, and how to go to that path or add that path to the command window so that from any other place you can run that file instead of going to that file. Then what is pwd and cd command that we'll see. In the script file also you'll use that. Then how to create a function, that is important. We can go to creating a function. What is a function file? That we'll discuss. Executing a function file, I gave you an example. We discussed an example of how an function file is executed by calling it from another script file. So these are two simple things about function files. Then we'll do some exercises. Once we have completed these things, or as we keep on moving through these points, we'll do some exercises. For example, one exercise can be uh, plot a sinusoidally plot a exponentially decaying sinusoidal curve, right? Which means you have to plot a function which is y is equal to exponential minus ax. Here I am taking a as 0 0.6. You can take it any value. Y is equal to exponential minus ax into sine x, and x is in the region 0 to 4 pi, which means x is in um, radians. If it is in degrees, then it will be sine dx. Sine and sine d, these are two different functions. Sine is for evaluating sine function in radian when x is in radian. Sine d is for evaluating sine function when x is in degree. So these are two different functions. So sine x and sine dx are two different values. Sine x, in sine x, x can be anything, any value. But in sine d, x can be between 362 minus 362 plus 360 or 0 to 360. Okay, so this is one. Then similarly, we can have another exercise like convert temperature from centigrade to Fahrenheit. Plus 2, you have read this example or formula F is equal to 9 by 5c plus 32. Write a program to convert that. Write a program for this conversion. You can write a program easily. So read C, then put the value of C. That will give you two functions, Celsius to Fahrenheit. So this can be another exercise that you can take up easily by the time we end today. Then there can be another exercise of how to make things simplified. So remove the skin. How to remove the skin of a complicated thing so that you can see or probe inside. For example, you are given a vector x. Vector x means x has many elements within it. So many numbers within it. Find the sum of the vector x, which means sum of all numbers within that. Suppose x is equal to 1 to 10. So find out what will be 1 plus 2 plus 3 up to plus 10, which is 55. So find out, write a program for that. Find the sum of the squares of these terms. So these are certain things that you can do always using a MATLAB program. So this is basically an introduction to what is MATLAB, what we can do with MATLAB, and what are the features available in MATLAB. In the next lecture that will start at after a break, we will take a look at the features or the application of the features, small simple examples that we'll see in the next lecture. Uh, Let me take a break for 2-3 minutes, then we'll come back and start. Yes, sir.